we would like to acknowledge the Wurundjeri Woiwurrung people who are the traditional custodians of this land, and we pay respect to the elders both past and present of the Kulin Nation and extend that respect to the culture and history that has been preserved. Hi, we're Team MJ², Maxwell Tong, Josh Gavan and Josh Hall. Today we're going to be presenting to you Cooling Footscray, which aims to create a modular solution to Footscray's growing urban heat problems, setting a precedent for future suburbs experiencing similar concerns. Footscray is located within the western suburbs of Melbourne, running alongside the Maribyrnong River. The area is transitioning into a more pedestrian-centric suburb. However, one of the largest barriers to this goal is the urban heat generated from its dense concrete-built environment. Lacking necessary shading and vegetation, according to the Cooling and Greening Maps of Melbourne, provided by the Victorian State Department of Transport and Planning, that brings together 3 databases recording Melbourne's heat, vegetation, and heat vulnerability index, we discovered a correlation between tree plantations and increased heat around Footscray. In particular, these highlighted areas had less than 10% coverage of trees ranging between 3 to 10 metres, whilst also having temperatures 5 degrees higher than the surrounding areas.
What is urban heat? Urban heat is the increased temperature experienced by large cities in comparison to rural areas. Urban areas tend to trap more heat than natural environments with average temperatures that are 1 to 3 degrees higher. Some urban communities are more vulnerable to higher temperatures because of the urban heat island effect, which occurs in urban areas where paved, dark-coloured surfaces such as roads, roofs, and car parks lead to heat being trapped. In the case of Footscray, there are early signs of the urban heat island effect. According to the Footscray structure plan, our activity zone areas are along a pedestrian priority route.
How effective are trees and vegetation at cooling urban environment? Trees work by absorbing solar radiation and store less heat than darker artificial surfaces such as asphalt and concrete. They also provide shade for surfaces and pedestrians, as well as cooling surfaces by up to 11 to 25% more than surfaces without shade. They also evaporate in cooling the surrounding areas. However, these trees need to be clustered together, as during extreme heat they can experience heat stress, which reduces their overall effectiveness. As greenery appears to be a strong solution against urban heat, precedent studies were looked into. This one is known as the Burwood Brickworks Shopping Centre by NH Architecture and Russell and George. The building fixates on many greenery strategies, which in this imagery shows a green wall system which comprises a structural system with potted plants gridded along it. Knowing this, a design was made using a similar formula. This design involves a grid structure with a mesh material fixed onto the external facade of the building. The mesh allows the plants to sit and grow on the structure itself. And to hydrate the plants, there is a plant care system which pumps water into pipes that are connected to these structures, which then drip water at a calculated pace onto the plants.
Using the Cooperative Research Centre's guidelines for passively irrigated landscapes developed by E2 Design Lab, we explored how to incorporate more vegetation into the streetscape to create more shading whilst also harvesting water and providing room for trees to grow to their maximum canopy potential. For street-side tree planting, drainage off of the street would flow through a drainage pipe into the soil. This water would collect in the subsoil. An overflow pipe located above the wicking zone would be connected to the stormwater drainage system. Similarly, for planting of turf, an inlet for stormwater would be located off of the street, filtering out sediment and debris. Feeding into a pipe was slotted distribution, which releases water into the gravel, with an overflow pipe set at the depth of the wicking zone, which is also connected to the stormwater drainage system.
As Footscray progresses into a pedestrian-friendly, public transport-dominated suburb, the need for its several multi-storey car parks has dwindled, leaving the majority underutilised. A potential solution, drawing from the University of Melbourne, involves widening the car park's structural columns to allow for the root system of trees, turning its underutilised concrete rooftop into a shaded, publicly accessible gathering space.